Hello guys, welcome back to another video. Today we're going to be discussing what is a function to kind of help you determine what is and what isn't. So going into the actual definition of a function is an expression, rule, or law that defines a relationship between one variable, the independent variable, and another variable, the dependent variable. For each input x, which is the independent variable, there's only one output, which is y. So looking at this example, we have two sides here. We have the x value and y values. They're the same for both sides, but we see that some x values are connected to different y values. And so we just want to determine which one is a function. There's one difference that stands out between both of them. Now, taking a look at the last slide, we see for each input, there's only one output. So this means there should only be one line that connects to an x. So here we see that each x has only one line, but this one, you see it has two. So now we can determine that the left is the function and the right is not. And to further explain this, I wrote out each of the ordered pairs. Now, when looking at an ordered pair, you want to make sure that each point only has one x value and one unique x value. So this one has 1, 2, 3, 4, 5. And if we come over here, we see that there's two ordered pairs that start with x equals 1, which deems this as not a function. Now for graph functions, we want to use something called the vertical line test. Now with any vertical line, this could be your finger, your pencil, honestly the edge of a paper, you want to run it along the line of the x-axis, and at any point, if there's 2 points on the function with air quotes, touching the vertical line, that's how we know it isn't a function. So let's take a look at the first example. As you can see, when the line was running through the graph, there's only one point on this line that was touching this line at all times. So this means it is a function. Let's take a look at the next one. So as you can see, any point past -3, there were always 2 points on this circle that were touching the vertical line, which means this function, air quotes, is not a function. And taking a look at the last one, you see, even though it got pretty close to touching 2 points at the same time, it only touched one each time it moves along the x-axis. So this is a function. The next thing we want to be careful of is functions with discontinuity. Discontinuity basically means that there may not be an x value along this whole function, or it's not continuous, basically. So taking a look at the first one, we have an infinite discontinuity. And basically what this means is that because of the asymptotes, the horizontal and vertical, the vertical indicates that x will never be equal to 3, and y will never be equal to 1. So as you can see, the y value uh, goes from 0.9999999 dot 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 all the way to negative infinity. And starting at the next one, it goes from infinity to 1.000000001. So, if understanding that, we know that there isn't going to be any value along this line, but that doesn't mean it's not a function. So this would be considered a function. And if we run the vertical line test, we know that there's never going to be more than one point on the line. What we have next is called a jump discontinuity. As you can see, we have this function and it kind of jumps up to, or about to. Um, and this at first can look like it doesn't pass the vertical line test, but we have to recognize that there is an open circle here, which means that there is not a point existing right here, although there is right here. So if we follow the vertical line test, we know that the only point existing right here is this point at x equals 3 and something around 1 for y. and it doesn't exist here. But the moment we get to 3 and a very, very small fraction, it exists up here. So this is a function as well. And the last discontinuity is a removable discontinuity. So you can see this function is continuous, which means you can just follow it along until this point, where there's kind of a hole, but there is a point existing, it's just not continuous with the rest of the function. But this is also a function. One of the biggest red flags we can see when determining if a set of numbers and variables is a function or not is seeing y squared, but specifically isolated. So I have the same example on both sides, but I simplified it so that we isolated y and x. And you can see that when we plug in one value for x, we would get two values for y. So here, if we plugged in 1 plus 3 would be 4, square root of that is 2, and when you square root something on both sides, you have to add the positive and negative sign because y could equal negative 2 and 2. It kind of makes more sense on this side if you aren't as well versed in math. So if we plug in 1 equals y squared minus 3, we add 3 to this side, then we get 4. But y can equal 2 and negative 2, and if it were squared, it would both equal 4. So we have two answers, which means that this would not be a function. But more specifically, that isn't always the case when you see a y squared. So looking at this example, we see that there's a y in the denominator and a y squared in the numerator. These eventually will cancel out, leaving us with 3y, which gives us an actual function. I hope this video was very helpful for you, and if you have any more questions, please leave it in the comments. Thank you for watching!